Alright, now we're looking at indirect proofs. For indirect proofs, we start off by taking what we're trying to prove and assuming the opposite of it. So for this, we're trying to prove that an odd number is not divisible by 4, which seems pretty obvious. And so we're given that x is an odd number. So if x is an odd number, then it's not divisible by 4. We start off by assuming that x is divisible by 4. And then what we're going to do is try to get back to the idea of it being an odd number and making it be a contradiction. For example, a contradiction would be x is an odd number and an even number at the same time. So in this case, that's what we're going to end up showing, is that it's an odd number and an even number, and since a number cannot be odd and even at the same time, that's where the contradiction falls. And so therefore our original statements have to be true, because the indirect proof shows that if we start with the prove and go back to the given, it's false. So by proving through contradiction that it's false, we know the original statement is true. So in this case, if we assume that x is divisible by 4, that's the opposite of what we're trying to prove. If we go backwards, first of all, we know that x over 4 is equal to some whole number n, and if we multiply both sides by 4, we get x equals 4n. Now what we're going to do is show that x cannot be an odd number and an even number at the same time. So if x is odd, then it can't be divided by 2. So what we do is we take these two things and we divide both by 2. So if we take x divided by 2, we get 4n divided by 2, which is 2n. So x divided by 2 is equal to 2n. And since we know 2n is a whole number, because n is a whole number, x can also be divided by 2. In other words, 2 times n is going to be an even number. So since 2 times n is going to be an even number, that means that n is going to be even and odd. And so that means x can be even or odd. And that's our big mistake there. That's our contradiction. So therefore, we have to assume that x being divisible by 4 is false, which proves that x is not divisible by 4. And we'll do one more of these. And this one's a little bit easier to understand, I think. So we have, if these things are true, then this is our conclusion. So we have this given to us, and we want to prove that this is true. So the temper assumption would be that x is equal to 9. And if x is equal to 9, then and y is equal to 5, then we would say x plus y is equal to, it's supposed to be not equal to 14. But if we know that these two things are true, because we're going to assume that's true, and we're going to assume the opposite of that is true, then we would have x plus y, sorry, not x plus y, but 9 plus 5 equals 14. So in this case, x plus y equals 14, but we were already told that x plus y is not equal to 14. Since both of these can't be true, we have to assume that this is true. Okay? So again, we would assume that x is equal to 9, since x plus y is equal to 14, and y equals 5 is given. By letting x equal 9, we lead to the contradiction that 9 plus 5 is not equal to 14, when in fact it is equal to 14. And that's it. Thanks.